Hello everyone, my name is Pandar and I am very thankful to say that we have been given the opportunity to present our school on Atmanirbhar Bharat Viksit Bharat Buildathon 2025 and our team name is The Area. We will be presenting our project titled Centrifugal Rocket Launch System. The project focuses on a new and efficient way to launch rockets using centrifugal force, something that could make space launches cheaper and more energy efficient. So let's begin.
In our traditional rocket launch system, we use huge amount of fuel to overcome Earth's gravity. But in our concept, instead of relying on rocket engines, we use centrifugal force to give a rocket an initial push. Like how a stone spins faster when you spin it around before release. This helps to reduce huge amount of fuel before a rocket launch.
Now let's come to the objective part. The main objective of a project is to design a system that can launch small rockets into the atmosphere using centrifugal motion. We wanted to explore whether this method could reduce fuel consumption, make launches safer, and lower the future cost of space missions.
The working principle is simple. When an object is rotated rapidly, centrifugal force pushes its output. In our setup, a rocket is attached to a rotating arm. When the arm spins at high speed, it builds enough energy to release the rocket tangentially. Just like a slingshot, after release, the rocket's own engine takes over to continue its flights into space.
So for our prototype, we have used basic components such as BLDC motors, servo motors, some aluminum foil rings, and an electric plastic channel so that it could hold the motor and the rocket at a place. And then we have also used Raspberry Pi and WebUIs to calculate the time interval when to launch the rocket so that it safely gets out. So now let us talk about design and conception. The design was inspired by the idea of circular motion. We built a rotating base connected to a high-speed motor and the rocket was attached at the end of the arm. We carefully calculated the radius, speed and release angle to ensure maximum launch efficiency. We also designed the structure to handle the centrifugal stress generated during rotation. Now let us talk about calculations and formula. To support our idea, we use the formula for centrifugal force, that is F is equals to m into omega square into r, where m is the mass, omega is the angular velocity and r is the radius. By increasing the angular velocity, we could produce greater outward force, giving the rocket higher initial velocity at launch. Our calculation helped us find the safe speed and radius for an efficient launch.
Now let's come to our working model. Our working model demonstrates how the rocket is spun and then released. We tested it at different speeds to see how far and fast the rocket travels. The results showed that centrifugal motion can indeed provide a strong initial thrust before engine ignition.
There are several advantages to this system. First, it reduces the amount of fuel needed. Second, it makes the launch process safer and cleaner. Third, it could make small satellites launches more affordable. And most importantly, it opens up a new way to think about space transportation.
Now let's come to the limitation. Of course, our system also has limitations. At very high speeds, structural stability becomes a challenge. Also, controlling the exact release angle and timing requires high precision and system required. But with better materials and control systems, those challenges can be solved in the future.
Future scope. In the future, the technology could be developed for launching small satellites or reusable rockets. We can improve the design using stronger materials, vacuum chambers, and computer-controlled release systems. It could even be used on the Moon or Mars where gravity is lower, making centrifugal launch system much more effective.
Now at last, to conclude, our project proves that its centrifugal force can play a huge role in future rocket launch systems. It's a step towards more sustainable and cost-effective space systems. Thank you all for listening, and I hope our idea gives you a new perspective on how innovation can change space science.